Thank you so much, Tolagele, for that particular question. As you can see, let's go in and analyze. I love analyzing. If you know me, you know I'm an analyst. So it says to us, each driver works 20 days per month and is allowed to take 2 drinks per day. So 20 days a month, 2 drinks a day. Already there, I can see what's going on. All the workers have been having drinks only at work and not at home. Some companies have that policy. And then it says the dimensions of a can, the capacity is 330 milliliters. The height is 115.2 millimeters. Okay? Capacity, anytime you hear the word capacity, just know it could easily be volume. Wonder if that is visible. Okay? So that is visible. So what we need to remember is that capacity is just another word for volume. Don't be scared when you see that. And if we're talking cans already, we're talking about cylinders. There we go. So we've been given that formula again. Like I said, you always will be given a formula. So don't go and cram formulas and waste so much time. Rather go study something else. Okay, don't waste time on cramming formulas. That's not what you want to do. So now we've been given the formula for this particular instance. And also, Tolagele, you did not give us the annexure. So because you didn't give us the annexure, then I cannot calculate 3.3.1. Let's look at what 3.3.1 is asking us. It says to us, a driver has been drinking Sprite and Coca-Cola for the entire month and claims his sugar intake takes up less than a cup. Verify those calculations. In order for us to do this, we need this annexure over here because it will tell us information on the sugar that we need to calculate. So I'm not going to do that one. However, I have chosen to do this one, which is out of 7. I didn't want to scrap out the entire question because I wanted us to still do it. It says to us, calculate the diameter in centimeters of a Coca-Cola can. First things first, we have been given the formula. I am going to rewrite the formula for us so that we can see what is going on. So I'm going to name that 1. So we are told that the volume of a cylinder is equal to pi times radius square times height. And we've been told that for pi, I'll just write that over there. We need to use 3,142. Please don't go and use your own thing, guys. Use the one that has been given. First things first, we have the volume of the cylinder. The volume of the cylinder is 330 milliliters. So I'm just going to write it over there. And then we've got pi, which is 3,142. We don't have a radius. So I'm going to leave that as it is. And we have a height, which is 115.2 millimeters. Okay, that looks visible to me. So now the caution that I'm going to give you is that we've been asked to give our answer in centimeters. So we need to be very careful of the measurements that we've been given, the units of measurement. So I'm going to do some conversions. That's why this is out of 7, guys. There's a lot of work involved. I'm going to convert everything, and I'm going to try and convert everything into something that's going to give us centimeters. Look at what I'm about to do. Concentrate. I hope you're concentrating, Tolagele. So first things first, I have been told that 1,000 milliliters is equals to 1,000 centimeter cube. That means, guys, these things are equal to each other, okay? So automatically, that 330 is going to remain as 330 centimeter cube. So it's important for you to know that, okay? Now, let's go convert this 115.2 millimeters into centimeters. You know how we have 10 in between them, okay? And if we are converting from centimeters to millimeters, we would multiply by 10. Going backwards, we would divide by 10. So it means that we are going to go back one space, which is going to become 11,52. Okay, I don't want that to be a mess. So I'm just going to remove this. Thank you. I'm just removing that so that I can see what's going on there. Neatness. There we go. So now I can tell what's going on, and now I can calculate my radius because I'm looking for the diameter. I know, right? That's why I need to know the relationship between diameter and radius, because radius, okay, I'll tell you that just now. Let's do our calculations. So what am I going to do? I'm going to eliminate these two by dividing them. I'm going to eliminate this one by dividing it. And what I do on the right, I must also do on the left. I'm dividing because of this multiplication sign going on over here. So when I bring it, let me just, so yeah, I need to clean that up so we don't think it's a minus sign. So there's just multiplication over there. So what I'm going to do, I can make it one long thing there just to say that's what I'm eliminating. What I do on the left, I do on the right. 3,142 times 11 0.52. Okay, so I'm going to be left with my R over there. Let's go use our calculator. Reasons why. Please don't use your calculator only in the exam, guys. It makes me so, I don't want to use the word angry, but it makes me sad that learners don't use their calculators in class, but they want to go use their calculators in the exam. Like, now you're using this foreign device that you've never used. Oh, there we go. Stunning. 9,12. I'm going to make it 9,12. Okay? 9,12. R square. How do we get rid of that square? We square root both sides. Okay? That square root is going to get rid of that. Long story. Doesn't really apply to this lesson. So, square root, ask your teacher one day, why? And then I'll tell them that I asked you to ask why. The square root eliminates that square at the top there. So my final answer, don't be scared, change, is going to be 3,02. I am rounding it off. 3,02. 3,02. That 3,02 is going to be 3,02 centimeters is R. Now I have my radius. Guys, this is out of 7, okay? So be patient with me. Now I've got my radius. If I have my circle, beautiful circle, the point from here, which is the center, to the circumference of the circle is called the radius. So I'm looking for the diameter. Diameter is double my radius because diameter is from here all the way to the other side. So it means that if I want to find my diameter, therefore, diameter is equal to radius times 2. So now I have a radius. Someone else would have said to me, why didn't I leave it as that 9? This. Because I'm still going to multiply by 2. Will you really get the same answer? Let's go find out. 3,02 times 2. 3,02 times 2. 6,04. That's my diameter. Let's look at the next set of questions that Tolagele sent us. So here we're working with cans, okay? Still the same thing. A can is in the shape of a cylinder, and it says to us the company decided to buy cans of Coca-Cola with an extra. So the moment you hear extra, you know that you're going to be adding, okay? The moment you hear extra, you know that you are going to be adding. So it says to us here, the company decided to buy cans of Coca-Cola with an extra 110 milliliters for the drivers. And it says to us the actual can is 440 milliliters. So automatically we know that for the drivers, it's going to be 550 milliliters because it is extra, okay? And then it says here that the height is 150 milliliters, the diameter is 2.41 inches. And then we have a young model over here. A model basically is something else that you're not really going to be using, but it's something to show what the can will be looking like. So let's calculate what we need to be calculating in terms of this one. The first thing that we are calculating is percentage difference. I believe I've said this before and I will say it again because it is important. Please know the formula for percentage difference. If you don't know the formula for percentage difference, you work your way around it, but you won't really get what you're supposed to be getting when you're supposed to be getting it. Maybe you spend a little bit more time in terms of that. Know your formula for percentage difference. Percentage difference is simply knowing the older price minus the new price, or the older can volume, subtract the new can volume all over the old. So I always say it's old minus new all over old times 100 because you are calculating percentage. Let's go calculate if the percentage difference really is 30%, because the question says to us here, use the information to calculate, and it says to us, the driver stated that the percentage increase in the volume of Coca-Cola can is above 30%. So we need to go and verify whether this is true or not. And if you don't get this answer, you're allowed to say the driver is not correct. Let's go calculate according to what the driver has said to us. So the driver here, I'm going to name that 1 again. The driver says to us it's going to be 30. Let's see. I said to you guys, percentage difference. Maybe I should just write percentage difference first. How do I know it's percentage difference? Because this person said the difference in percentage. Difference is equals to old minus new all over old, because you're comparing it with the older price, times 100. And in this particular case, because we are working with, okay, let's see how this is going to work out for us. So I'm going to say 550 minus 440. I'm just trying to confirm this formula for you guys, okay? Is going to equal to 110. But that's not really what I'm looking for. I'm looking for the percentage increase, because I want to know, is it true that this percentage increase is really going to be what they say it's going to be? Is it really going to work out the way that I want it to work out? So this is going to give me 110 milliliters. What do I do with this 110 milliliters? I have to divide it with the old price. Why am I dividing it with the old price? Because is it really an increase from the old price? So that's going to be 440 milliliters, and then I need to multiply that by 100. Okay, That's very interesting. Look at what I just did there. 440 minus 550 all over. Is it really going to give me the same? I want to actually prove these against each other. 110 okay. Is it taking me to where I want to go? All over 440 times 100. It's 25. Okay? So now we can see that it's a 25% difference. I want to just quickly prove it on top of the formula that I've just given to you guys, because I don't want to give you something that does not work in all instances. So I said to you guys, old minus new all over old times 100. We want to see if it's going to give us the same as this. Okay, I don't want to give you guys false information. Old is 440 milliliters minus 550 milliliters all over 440 milliliters times 100. Look at what I just did there, guys. I don't want to give the wrong information. Something is not working properly. 440 minus 550. No. 440 plus 110. Oh, stunning. I thought that was incorrect. So it's going to be 440 minus 550 all over 440. Okay, I'll just multiply that in the end. There we go. There we go. So it gives us the same answer, okay? In this case, it just gave us a negative answer, which means it's exactly the same. So you are safe in terms of using that particular formula. I didn't want to give you guys something that you can't use, and then you end up in the end, and then it's like, that lady told me to use it, okay? So it means therefore the driver is not or is incorrect. You're allowed to say that, guys. I find that sometimes learners will try to manipulate their answer to look like the answer that's been given in the paper, because they somehow think that the answer that's in the paper is always the correct one. It says to us, verify whether this person is correct or not. And for me saying at the end that this driver is not correct, I get a mark for that. And if we look at this, it's actually 4 marks. I get 3 marks for the calculation and 1 mark for saying this guy is not correct. And you're allowed to say that. You're allowed to say, or otherwise they wouldn't have given you the freedom to say, verify if this is correct or not. The next one says to us, determine the scale and then calculate the diameter. Remember that the diameter was initially given to us as 2.41 inches, meaning that we are going to have to do a young conversion over there. So it says to us, determine the scale, then calculate the diameter in millimeters of the model. So we are sitting with the original and then we're sitting with the model. I want you guys to look at this. There we go. So this is the original can, this is the diameter that we've been given, and then this is the height that we've been given. Then this is the model can, meaning that it's not the real can, but it's what the can should be looking like. So it's smaller. The height of this one is 45.5, so you can see that it's smaller than the actual can. And then we have not been given the diameter, so we are being asked to calculate the diameter. how we're going to do this, it means that we need a scale from it, and then we need to determine how to work it out from there onwards. This is how I would do it. I'm going to call that 2, and I'm going to say that because the height of the original, I'm going to say height of original height of original versus the height of the model, because that's what I've been given. Okay, height of the original is 150 millimeters, and the height of the model is 45.5 millimeters. And I also like saying to you guys, if you want to check it out, go to your calculator. So 150 all over 45, oh no, sorry, it's the other way around. Let's just say 45.5 divided by 150. So the number just becomes bigger. So it doesn't really help like that, okay? So the scale will then remain. This is going to remain as it is, being the scale. And then I like to use a little thing that I call moving from known to unknown. What do I know? First things first, before I can do the known to unknown, the first thing that I need to do is put my height under my height. 150, and then I'm going to put is to 2.41 inches. Whenever you have something like this, you cannot have it like that because we have been given everything in millimeters. So you know you're going to have to do a conversion somewhere, somehow. 45.5. So the X is what I'm looking for. But now I want to convert this into millimeters. Let's go do some rough work. So I'm going to say, if I'm working from known to unknown on the side, but I'll erase it, is that I know that 1 inch is equals to 25.4 millimeters. Please don't go cram it. You will be given. Okay. So now inches under inches, 0.41. And then I want to find out what it is in millimeters. So I need to multiply those two and divide by that one. Let's go use it in our calculator. That's going to be 25.4. 25.4 times, we're going to be multiplying that by 45.5. Let's see. Sorry, that's going to be by 2.41, sorry. 2 multiplied by 2.41, nice one. 61.214. So this is going to be, okay? So now I know what my X is going to be, and my X is my diameter. So let's see how I would do this cleanly and nicely. So my X is going to be 61.214. That then tells me where all those marks are coming from, because I'm sitting with a big bunch of marks and I'm not sure where they're coming from. Therefore, I'm doing my moving again. This is actually the inches that I'm looking for. Sorry for that. 214. So it's not this. So now I've found my inches and I've moved it. Okay, stunning. Now I can multiply. I cross multiply these two and I divide with the one that I didn't use. So I cross multiply the two that exist with each other. I divide with the one facing the X. Let me call it that. So it's 45.5 times 2.41 But I can't use that 2,41 because I had to go and convert it to 61.214. Did you see what I did over there? I made sure that I'm using the millimeter ones because this is the millimeter. It's us converting those inches into millimeters. Let's go down. We divide it with the 150 and let's see what it's going to give us. 45.5. I'm going to multiply it with that number already. Divided by 150. 18.57. What is this 18.57? This 18.57 is going to be the diameter of the can. Therefore, (18.57), and we are asked to give our answer in millimeters.